Today's lesson is all about solving right triangles using trig functions, sine, cosine, tangent. Please remember that solving a triangle means to find all unknown sides and unknown angles. So in practice, that means there will be three things that you're trying to find for each triangle. For example, in number 1, there are 2 missing angles and a missing side. On problem number 2, there's 1 missing angle and 2 missing sides. There will always be 3 things. So when you're finished with each problem, there should be 3 answers that you have boxed. Let's see. So let's go ahead and find angle A. If I want to find angle A, and I'm noticing that I have my 9 and my 12. Looking at these 3 things, this is adjacent, this is opposite, so this is going to be my tangent function. So I'm going to go tangent A equals opposite over adjacent, so 12 over 9. That means A is equal to the inverse tangent of 12 over 9. And then I'm going to put that in my calculator. And I'm getting 53.1 degrees. All right, so that's the first of 3 things I need to find. Once I have angle A, finding angle B should be easy. That's just going to be a matter of doing 90 minus 53.1. So that's 36.9 degrees. So that's 2 of the 3 things I need to find. So I have my angle A and angle B. Now I just need to find side AB. Okay, as I go to find side AB, so look, I'm just going to call it AB. I am not going to use the angles I just found. If I got angle A wrong, then I'm going to get multiple problems wrong. So it's better to use the information that's given. Pythagorean theorem is the way to go to find AB. So I'm going to go AB squared should equal 9 squared plus 12 squared. Then if I take the square root of both sides, whoops, I guess I didn't mean to quite do it like that, but whatever. That's going to give me what AB is. Okay, so AB should equal, and I'm just going to put that right in my calculator as it is. So really, I would just type this into my calculator like this. I would get away from squaring the 9 and squaring the 12 and doing all the steps separately. Let your calculator do that work for you. So it's 15. So AB is equal to 15. So there's the 3 things, 1, 2, 3. So number 2, let's start by finding this angle B, the missing angle. And of course, that's just going to be 90 minus 38. So that's 52. So angle B, let's get that out of the way. Angle B is 52 degrees. Okay, now the rest of it. So we also need to find these 2 missing sides. So let's find AB first. It doesn't really matter, but so I'm just going to call this AB because that's what it is. So looking at the angle that I've got, okay, looking at the angle that I've got and looking at the side I'm given and looking at the side that I'm trying to get, what I have is opposite and hypotenuse. Opposite and hypotenuse, that is the sine function. So that's why I'm going to go sine of 38 is equal to 12.5 over AB. Okay, opposite over hypotenuse. When the unknown is in the denominator, that is when I do this reversal, and I put the AB out here, and so this will be 12.5 over sine 38. So that's going to give me AB equals 20.3. So now we need to find AC, which is right here. So again, looking at the angle that I'm given, looking at the side that I'm given, and looking at the side that I'm trying to find. What I have here is opposite and adjacent. So that is the tangent function. So I'm going to do tangent of 38 is equal to 12.5 over AC, opposite over adjacent. So again, the variable is in the denominator, so I'm going to do this reversal. So that's going to give me that AC is equal to 12.5 divided by tangent 38. And I'm going to put that answer over here. AC is equal to 16.0. All right, 1, 2, 3, I'm done. On every problem, make sure you have 3 answers. Okay, let's do problem number 3. Okay, I need to find 2 angles and a side. Let's start with angle A. So looking at angle A, and I've got the 3 and the 2. That is adjacent and hypotenuse. That's the cosine function. So I'm going to do cosine of A is equal to 2 over 3, adjacent over hypotenuse. That means angle A is equal to the inverse cosine of 2 over 3. You must show both of these steps. So that's going to give me A equals 48.2 degrees. So then I can easily find angle B by doing 90 minus 48.2. And that's 41.8 degrees. So there, I've got angle A, and now I've got angle B. All that's left is to find side BC. Side BC, of course, is right here. I've got 2 sides given, trying to find the third side. Please use the Pythagorean theorem. Do not use the angles that you just found, just in case you made a mistake and these are wrong. So we will do a squared plus b squared equals c squared. So this would be like having 2 squared plus bc squared is equal to 3 squared. Why does the 3 go by itself instead of the bc? The hypotenuse always goes by itself. So then we're just going to subtract 2 squared from both sides. So that's going to give me bc squared is equal to 3 squared minus 2 squared. Okay, fine. I will go ahead and do this manually. So bc squared, so that's 9 minus 4. So bc squared is equal to 5. So that means that BC is equal to the square root of 5, because of course we got to take the square root of both sides. All right, but maybe you would prefer a decimal. That would be 2.2. So there's BC. All right, then, number 4. We need to find an angle and then 2 sides. Let's find the angle first. We can find this angle by doing 90 minus 59. So that's going to give me that angle B equals 31 degrees Okay, so now we can find the two sides. So let's see, which side shall we find first? Let me get this out of the way. Let's go ahead and find, let's find AC first, because why not? So here's AC. I'm just going to call it AC. So looking at the AC and looking at the angle that I'm given and looking at the 16, what I have here is adjacent and hypotenuse. That is the cosine function. So I will do cosine of 59 is equal to adjacent, which is AC, over hypotenuse. Because the unknown is in the numerator, then I'm just going to multiply by 16 on both sides, like this. Okay, that way these 16s are going to cancel each other out. And that's going to give me that AC equals, and I've just got 16 cosine 59, that's 8.2. So AC is equal to 8.2. So we found AC. Now we need to find BC. BC is right here. So looking at the angle and the BC that I want and the 16 that I've got, what I have is opposite and hypotenuse. That's the sine function. So I'm going to do sine 59 is equal to opposite over hypotenuse. Once again, the unknown is in the denominator, so I will simply multiply. So these 16s cancel each other out, and that's going to give me BC equals 16 sine 59 in the calculator, 13.7. All right, was that all three things? 1, 2, 3. So that one's done. Okay, number 5. Okay, two angles and a side. Let's start with angle A. If I want to find angle A, I'm going to use the 6 and I'm going to use the 12. So what I have there is adjacent, and this is opposite. Opposite and adjacent, that's the tangent function. So I'm going to go tangent of angle A is equal to 12 over 6, opposite over adjacent. That means angle A should equal the inverse tangent of 12 over 6. Calculator time. Well, that's 63.4 degrees. So that is angle A. Might as well go ahead and find angle B, since all I have to do is go 90 minus 63.4, and that's 26.6 degrees. So we have angle A and we have angle B. Now we just need to find side AB. Where here's unknown side AB, I'm just going to call it AB. Let's use the Pythagorean theorem since we're given two sides. So that's going to look like this. AB squared is equal to 6 squared plus 12 squared. If I take the square root of both sides, and again I can just put this whole expression right in my calculator, that's going to give me AB equals 6 radical 5, which if I need a decimal is 13.4. Okay, so that's number 5. Let's look at number 6. We might start by finding angle B, because that's the easiest. All we need to do is do 90 minus 61. So angle B is 29 degrees. All right, now let's find side AB. So here's side AB. Looking at the angle and looking at side AB and side 5. What we have here is adjacent and hypotenuse. Adjacent and hypotenuse, that is the cosine function. So cosine of 61 is equal to 5 over AB. Since the unknown is in the denominator, that's when we do the reversal. So this is going to give me AB equals 5 over cosine 61. So that means that AB is going to equal 10.3. So that's AB. So we still need to find BC. Okay, well here's BC right here. So looking at the 61 and looking at the 5 and the BC, what I have here is opposite and adjacent. Opposite over adjacent is a tangent function. So I'm running out of space here. I'll just do it over here. So this is going to be tangent 61 is equal to opposite over adjacent. So BC over 5. Since the unknown is in the numerator, I can just multiply. So I'll just multiply by 5 on both sides. Okay, so 5 tangent 61 should be my answer. I think I'll just put it back over there. So BC is equal to 9.0. All right, did I find all three things? 1, 2, 3, yes. So moving on to number 7. So for number 7, we need to find an angle and two sides. Let's start with the angle. All right, that's just going to be 90 minus 51. I feel like we just did this. So angle A is 39 degrees. All right, so let's go ahead and find side AB now. So side AB is right here. So looking at this angle and the AB and the 3. What we have here is adjacent and hypotenuse. Okay, that is the cosine function. So we will do cosine 51 is equal to the adjacent leg over the hypotenuse. Since the unknown is in the denominator, I will do the reversal. So this is going to become AB is equal to 3 over cosine 51. And I'll just put that in my calculator. That is 4.8. Okay, so AB is 4.8. That just leaves one thing to find. We need to find side AC. So here's side AC. Looking at the 51 and the 3 and the AC, that is opposite and this is adjacent. So that is the tangent function. So I will go tangent 51 is equal to opposite over adjacent. In a case like this, we just multiply both sides by the denominator. That will get AC by itself. So that means that AC equals 3 tangent 51. Calculator time. That's 3.7. Okay, number 8. Let's find angle A. We will just do 90 minus 53. So angle A equals 37 degrees. Let's find side AB. So here's AB. We've got our 53 and the 2. Look, this is opposite and hypotenuse. So that is the sine function. So we will go sine 53 is equal to opposite over hypotenuse. The unknown is in the denominator, so we will do the reversal. So that's going to give us AB is equal to 2 over sine 53. Just put that in the calculator. That is 2.5. Okay, so 2 down, 1 to go. Now we just need to find BC. Here's BC down here. Looking at this angle and the 2 and the BC, we have opposite and adjacent. That's going to be the tangent function. Running out of space, I'm going to do it over here. So the tangent of 53 should equal opposite over adjacent. We will do the reversal, so that's going to give us that BC is equal to 2 over tangent 53. So BC is equal to 1.5. By the way, all this work that I'm showing is mandatory. If you're missing any of these steps, you're going to be losing points. Okay, this is kind of a long homework assignment. Number 9. We have 2 angles and a side to find. Let's start with angle A. So looking at the 3 and the 3, that's opposite and adjacent. So that is our tangent function. So we will do tangent A is equal to 3 over 3. That means A is equal to inverse tangent of 3 over 3. That means that A is 45 degrees, which we really knew because since these were the same. But there you go. So A is 45 degrees. Guess what? That means that B is also 45 degrees because it's isosceles. These are going to be the same. So that's 45 degrees also. So that means all we really need to find is AB. Okay, so let's call this AB. Pythagorean theorem. So, well, actually, you know what? Since we know this is a 45-degree angle, let's go back and use our special triangle knowledge. Remember, for a 45-45 triangle, it's going to be leg, leg, and then leg radical 2. So AB should equal 3 radical 2. And you could turn that into a decimal if you want to. If you do the Pythagorean theorem, you get the same thing. Okay, number 10. Let's find angle B. So we'll find angle B by doing 90 minus 65. So angle B is 25 degrees. Okay, now let's go ahead and find side BC. So here's side BC. Looking at the 65 and the 13 and the BC, what we have is opposite and hypotenuse. That's the sine function. So sine 65 should equal BC over 13. We'll just multiply both sides by 13. That way these 13s will cancel each other out. That gives me that BC equals 13 sine 65. That's 11.8. Alright, that's BC. How about AC? Well, here's AC over here. So looking at the 65 and the 13 and the AC, this is adjacent and this is hypotenuse. So that is going to be the cosine function. So we will do cosine 65 is equal to AC over 13, adjacent over hypotenuse. Multiplying by 13 once again. That way these 13s will cancel each other out. And we're going to find that AC equals, and we'll just put 13 cosine 65 in the calculator. And that is 5.5. Okay, that's our three things for number 10. Number 11. Okay, we need to find two angles and a side. Let's find angle A. Angle A is just going to be found by doing 90. No, it's not. Let's find angle A. Angle A will be found using the 9 and the 16. That's adjacent and hypotenuse. That's the cosine function. So cosine A is equal to 9 over 16. That means angle A is equal to the inverse cosine of 9 over 16. Just put that in your calculator. And that is 55.8 degrees. That means angle B, we can find that by doing 90 minus 55.8. That is 34.2 degrees. So that's two things. We just have one more thing to find. And that is going to be side BC. Pythagorean theorem. We're given two sides, so let's go BC squared plus 9 squared is equal to 16 squared. That means BC squared is going to equal 16 squared minus 9 squared, because I subtracted. And then I need to take the square root. So if I take the square root of both sides, like this, then that's going to give me that BC equals. Now I'm just typing the square root of 16 squared minus 9 squared in my calculator. Okay, that is 5 radical 7, which is the same thing as 13.2. Well, it's approximately 13.2. Okay, so there's our three things for number 11. How about number 12? We definitely need to find angle A. So let's do that. So we'll find that by doing 90 minus 72. So that's going to be 18. So angle A is 18 degrees. Now let's find side AB. Well, looking at the 72 and the 2.7 and the AB, this is adjacent and this is hypotenuse. So that's the cosine function. So let's go cosine 72 is equal to adjacent over hypotenuse. The unknown is in the denominator, so we will do that reversal that we often do. So that's going to give us that AB is equal to 2.2 over cosine 72, which means AB equals 7.1. Okay, so now we just have to find AC. So here is AC. Looking at the 72 and the 2.7 and the AC, this is opposite and adjacent. So that is the tangent function. So we will do tangent 72 is equal to opposite over adjacent. So in this case, we'll just multiply by 2.7. Okay, so that's going to give me AC. AC equals. So 2.7 tangent 72 goes in the calculator. And that is 8.3. Alright, so that's it for number 12. Alright, I think we're down to the last two. 13 and 14. So we need to find angle B, so let's do that. We can find angle B just by doing 90 minus 49. So that means angle B is going to equal 41 degrees. Okay, now we need to find the two sides that are missing. Let's start by finding AB. Well, you got your 49 and your 8 and your AB. That is opposite and hypotenuse. So that's the sine function. So let's go sine 49 is equal to opposite over hypotenuse. The unknown is in the denominator, so let's do our reversal. So that's going to give us that AB is equal to 8 over sine 49. So that tells us that AB equals, in the calculator, 10.6. Okay, so that was AB. That just leaves AC, which is here. So looking at the 49 and the AC and the 8, that is opposite and adjacent. So that is the tangent function. So we will go tangent 49 is equal to opposite over adjacent. Unknown in the denominator means let's do this reversal. So that means that AC is going to equal 8 over tangent 49. That means AC equals 7.0. Okay. Last problem, because we found all three things for number 13. Alright, so for number 14, we will need to find angle B. Of course, we will do that by doing 90 minus 55, which means that angle B is 35 degrees. Okay, so let's go ahead and find AC next. So here is AC. Looking at the 55 and the 4.8 and the AC, we have adjacent and hypotenuse. So that is the cosine function. So we will do cosine 55 equals adjacent over hypotenuse. So AC over 4.8. And then we will multiply both sides by 4.8. So 4.8 on both sides. The 4.8s cancel each other out. So that's going to leave me with AC equaling 4.8 cosine 55 in the calculator. That is 2.8. Okay, so that leaves only one more thing. We need to find side BC, which is here. So looking at the 55 and the 4.8 and the BC, that is opposite and hypotenuse. So that's the sine function. So we will do sine 55 is equal to opposite over hypotenuse. And we will just multiply by 4.8 on both sides. That way these cancel each other out. And that tells me that BC equals 4.8 sine 55. So BC equals 3.9, and that is the end of this assignment. That was kind of a long one.